Okay, can you hear me? Can you see the geometer sketchpad?
Yes, teacher.
Yes. Can see and can hear, huh? Okay, right. So we come back to this. Oh, if you look at the chain here, the chain here consists of one arc, the small arc, the big arc, and the two tangents, here. Tangent no need to find, it is given. Okay, so we find the two arcs here, two arcs. So that is why I proceed to find the arc length. So for the small circle, the arc length is S1 equal to R1 theta 1. So S1, write down S1. R1, you remember just now I told you don't simplify, just leave it as 30.5 over 2 pi. Yes, just leave it like that. Then the angle is 160 degrees. Now, can you use 160 degrees? No, you have to convert to radian. So you multiply by pi over 180. You multiply pi over 180. Now, in this way, you see that the pi and the pi can cancel. The pi and pi can cancel. Right? So when you cancel the pi, you get the answer 13.55556, which is quite accurate, because if you have earlier on substitute in the pi, then now you divide by pi again, your answer will not be accurate. So you see the reason why I asked you to keep the radius in terms of pi is because afterwards we can cancel with the pi here, right? And we can get a quite an accurate answer for the arc length. Okay, for the first circle. Now for the bigger circle, S2 equals to R2 theta 2. S2 is this side, the arc length. R2 is this one, 50.8 over 2 pi. This one here, the R2 here. So substitute inside here. Then the angle theta 2 is 185 degrees. So 185 you convert to radian, multiply by pi over 180. So you see that the pi and pi can cancel, and you have 50 times 185 over 360, which is 26.11. So if you want to find the length of the chain, you add the two arc together, arc of the small circle, arc of the big circle, and the two tangents you add together. So the answer is 89.66. Correct or not? Someone please check the calculation. 89.66. Okay. Use your calculator to check.
Yes, teacher.
Correct, 89.66.
Ah,
Okay. Right. So once again, I want to remind you, we are going to find the arc, small arc, sorry, not small arc, arc of the small circle, arc of the big circle, plus the length of the two tangents, So before you find the arc of the two circles, you have to find the radius of the two circles. How to find the radius of the two circles? Can, because they give you the circumference. From the circumference, you can find the radius of the small circle and the radius of the big circle. However, don't calculate this number. Don't use your calculator, calculate it and make it into a decimal. If you make it into a decimal, then the answer is not accurate. And this not accurate answer you put in and calculate one more time, it becomes more inaccurate, right? So you just leave it in this form and leave it in this form. Don't calculate. Then we proceed to find the arc length. S equals to r theta. R, you substitute in this expression here. Theta, you change the theta to radian. Okay, in this way you see that the pi and pi they cancel off, and you can get quite an accurate number for the arc length of the small circle. Use the same method, find the arc length of the big circle. find the arc length of the big circle, right? So you add the two arc length together and add the two tangent, you will get the length of the chain, the length of the chain. So any question regarding this thing here and here? No, not?
No, teacher.
No. Anybody else got question or not? You just ask, turn on your mic and you ask. Okay, no. No, then we move on to area of a sector. Area of a sector. Okay, no question. Very good, uneven. Okay, now the area of a sector, I told you last week, half r square theta. So how many variables are there in this formula? 3. A, which is the area of the sector, r, which is the radius of the sector, and theta, which is the angle subtended at the center in radian. Must remember in radian. In degree, tak boleh terima. So there are 3 variables, A, R, and theta. 3 variables. So given 2 variables, you must find the third one. And if you alternate them and so on, you will get 3 cases like this. Sometimes they will give you R and theta, ask you to find A, like this question here. Sometimes they will give you A and theta, ask you to find R. And sometimes they will give you A and R, ask you to find theta. So you see the MS question like that, right? So the 3 variables, they give you this 2, ask you to find this one. Or give you this 2, ask you to find this one. Rotate, right? So what I mean by this, you look at this example here. Look at this example here. Now, there is a sector, right? And the radius is 5. You are given the angle. Now, unfortunately, the angle given is the reflex angle. The reflex angle. It is not the acute angle. Now, this acute angle is the angle of the sector. But the other side, the reflex angle of this is not the angle of the sector. So we have to find the angle of the sector. How to find the angle of the sector? So you have to use 360 degrees minus the reflex angle, then you will get the acute angle. So it's something like this, right? It's something like this. Okay. Now, the acute angle AOB, this is the acute angle AOB, this one, acute angle is 360 minus 300, and the answer is 60 degrees. But this is provided the angle given to you is in degree. Given to you in degree, then you can use degree minus degree and you get the angle in terms of degree, the angle that you want in terms of degree. However, the angle given to you, the reflex angle given to you, is the angle in radian. How are you going to use 360 minus radian? So this is what we are going to do. 360, instead of 360, you write down 2 pi. You see, I told you to memorize the table, right? No? You have to memorize the table, right? You have to memorize the table. So 360, instead of using 360, I use 2 pi. And the reflex angle actually is 300 degrees. But you don't know. You don't know it's 360 degrees unless you do the calculation like this. Then you know the reflex angle is 360 degrees. But it is not necessary that you convert the angle in radian to degree, because even if they give you in degree, you are not going to use it, right? So we might as well find the answer in terms of radian. So instead of writing 360, you write 2 pi. And this 300 we don't know. We only know that it is 5 over 3 pi. So the angle here is 2 pi minus 5 over 3 pi. So the angle here is 1 over 3 pi, or 1/3 pi. So far, can understand what I'm talking about or not? I show you in degree and show you in radian. Can understand or not? I want to some response from you so that I can sambung. Okay, can. Li Ying can. Then other students can or not? Can. Okay. 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 So you can understand, right? Understand. Okay. Okay. Good. Okay. So now I want to find the area here. Okay. So area is what? Area is half r square theta. Half is always there. R, I look at the diagram. Oh, R is 5 cm. So I put 5 square. Angle theta. Oh, just now calculated already. 1/3 pi. So put down 1/3 pi. So it is not necessary to convert the angle into degree, then convert back to radian again to substitute inside here. So there's a direct link. You just use 2 pi minus 5 over 3 pi and you get the answer. Okay, exactly in radian, put inside. So answer is 13.09 centimeter square. Like very simple direct use of the formula half r square theta. No tricks except this one. This one maybe you think is a trick. Okay, so you have to memorize it. Okay, right. Now we come to this one, the question number 3. Okay, the diagram shows a major sector EOF. Okay, EOF, and the radius of the radius is R, area 195. So they tell you the area is 195. This area, the yellow color area, 195. But the R they didn't tell you, so you have to find the R. You know area, you know angle, don't know R. Now this is the one, the second case here. Given area and angle, find the radius. This is the second case. So don't be afraid. You already learned in your moral. Berani kerana benar. Benar kah? Benar. I remember the formula, right? The formula is A equal to half r theta. So I really know. And this formula is given if you look at the exam question booklet. The exam question booklet like this. Here's the SUM question, right? Exam booklet like this. And you open up the first page. All the formulas there. So this one, this one is where? Oh, not on the first page. Maybe one more page. Next page. Yes. Where is it? Okay. Right. So what you need to do is, don't be afraid. You know this topic is about radian, so you just open up the formula in front of the question paper, copy down the formula. So when you copy down the formula like this, then you think of numbers to put inside the formula. Once you put number inside the formula, 1 mark. Anybody get 0 for the exam or not? Never mind. When I mark the paper every year, their girls get 0, 0. One girl or two girls they get 0. Maybe the form 1, form 2, form 3 they never learn mathematics. Right? But for your case, copy down the formula, then put down the numbers, 1 mark. Right? So what is the number? Area 195. Radius, don't know. Angle 3.9. Angle 3.9. Just put inside. So the rest you have to know how to change the subject of the formula. So I make r square the subject of the formula. So r square is 2 times 195. The 2 bring on the other side. 2 times 195. Then divided by 3.9. This 3.9 go down. 3.9. But this is r square. So you want to find r, you have to take square root. Take square root. The square root. Oh, I get a very nice number. 10. Exactly 10. Very nice number, right? So now what I know the radius, what they want me to find? The value of r in cm found already. The major arc length EF. Where is EF? This one. Arc length, or they want arc length. You know the formula for arc length or not? Look at the exam paper. Open. Look at it. So the formula is S equals to r theta. Then you put in all the numbers that you know. R you found earlier here 10, then put inside. Angle given in the question 3.9, put inside. So you have 3.9 times 10, 39 cm. So if you want to find the perimeter of this yellow color, how many lines are there? 3 lines. One is the arc, one is the radius, and the other one also radius. So you add the arc plus radius plus radius. So 39, given here 39, radius here, then add them up, answer is 59. So you know how to make use of this formula or not? If okay, then I will move on to the last example. Okay or not? Can follow? Can. Being can. Some more? Anybody else? Can. Ang Li-wen also can. Okay. So can I go on to the next question. Last question here. Now this last question, this one quite difficult. And the exam question is like this, and more complicated one, like inside the revision exercise in your textbook. They are very difficult already. And exam is not simple one, it's difficult like this. Okay? Right. Now another thing is what is given in the diagram. I use green color. Now the red color is the one that I found out, so it's not given. The red color one is not given. Even the F here not given. These are the things that I add into the question to help me to solve the problem. You see, they give you a problem like that, and you cannot actually straight away find one. That's why there are so many people they cannot do at maths, because cannot straight away find. Okay, so now we look at the problem here. The problem, there are two discs put side by side, one big, one small, put side by side, and placed on the table. So this table is actually the common tangent, like just now. This table, the flat line PQ, this line PQ, is actually the common tangent of the two circles. It's common tangent. Okay, right. Now what is given by the question is the radius is 11 and the radius is 7. So here is 11 and here is 7. It's given in green color. Okay, then nothing given already. They just give you these two lines only. Angle not given lah. Other length also not given. Everything not given. So you you must really think this type of question. That's why I want to bring up this type of question. Okay, so I copy this pink color. It looks like a trapezium, and indeed it is a trapezium. Why you know it's a trapezium? You see the right angle here, the blue color here. I make it bigger. I make it bigger so that you can see. Hmm? Can you see the right angle here? Right angle here, because they say this one is the tangent. They didn't say tangent, but you know it's tangent because you rest it on the table, it has to be the tangent. So you can see the two right angles here. So once you can see the two right angles here, that means these two lines, they are parallel. AD and BC, they are parallel. And if they are parallel, that means this whole shape ABCD, ABCD is a trapezium. ABCD is a trapezium. Okay, right. Okay. So ABCD is a trapezium. So I copy out, and there's nothing known, only these two lines, 11 and 7. Okay, so how are we going to do? Let F be the foot of the perpendicular from B to AD. So from B here, I draw a line towards AD. This line is AD. So from B, I draw a line, cut across the trapezium, and this line is a perpendicular line to this side AD. Then I label this point where they cut the foot of the perpendicular. In English we call it foot of the perpendicular, and I call this F. I call this point F. So the point F, make the line segment FB. This is FB here. So this FB drawn by me, question never tell, question never tell, is drawn by me, and I call this point F, and this line FB, they cut the trapezium into two parts. One above, right angle triangle. One below is a rectangle. So the line FB cuts the trapezium into two parts. This one is drawn by me. Why I want to draw like that? Okay, you see. We see why we have to draw like that. So once you draw like that, this side is 7. This side is also 7. So the remainder at the top is 4. Why? Because the whole thing AD is 11. FD same as BC. This one is 7. So what is AF? AF is is 11 minus away the 7. So we see this one. AF is 11 minus 7, which is 4 centimeter. Then there's another line that we know. There, the other line is AB. Why I say I know AB? Because AR is the radius. BR is also the radius. The two circles, they are touching each other at the point R. The two circles, they are touching each other at the point R. So from R to A is the radius. From R to B is also the radius. So if I want to find the whole hypotenuse of this right angle triangle, is 11 plus 7. So AB is 11 plus 7, which is 18. Okay or not? From the trapezium, I get a right angle triangle and a rectangle. Now everything about this right angle triangle at the top there, AFB, I know everything already. So far, can follow or not? Can you understand how I get 4, 11, and 7? You can, then you put a thumb there. The check there, you put a thumb. Bagus, bagus. Thumb. Just put a thumb there. Only Sherwin. Other people, other students? Okay. Some more? Okay, right. So boy said can. Right. So now I copy this right angle triangle, Salin, then put here in front of you. Put in front of you here. Now this right angle triangle, ABF, okay, I call it ABF. This right angle triangle, I only know two things, 4 and 18. 4 and 18. So even this 4 also, I pick up, then I get this 4. Even this 18 also, pick up, then I know it's 18. It's not given in the question. Pick up, baru tahu. Now, if you want to, find the angle here, because you see, okay, we refer to this part. This is the shaded part. They want us to find the area of the shaded part here. But in order to find the area of shaded part, we must know the angle A and the angle B here. Now this angle A is actually will give us the area of this sector. The angle at B here will actually give us the area of this sector here. So we want to find the area of the two sectors. So to find the area of two sectors, you have to find the two angles here, this angle here and this angle here. Now this angle here, we don't know. But I know trigonometry. Right? So I know trigonometry, yeah. So not this one, so I know trigonometry. So trigonometry here tell me this, you want to find the angle A here, BAF. BAF. I want to find this angle here. I use cosine, because this is adjacent, this is hypotenuse. So adjacent over hypotenuse, 4 over 18. Cos BAF is adjacent over hypotenuse, 4 over 18. So because this is cos, I must find the arc cos. Many students, they call this shift cos, because the calculator, there's a shift button. They press shift, then they press cos. So they say this is shift cos. Now shift is actually the calculator button. The correct way of reading this is arc cos. ARC, arc, same as the arc length, the spelling same as the arc length. So this thing is called arc cos, arc cosine. Now if you remember what you have learned in your Form 4 function, cosine is a trigonometric function. Arc cos -1 means the inverse function, of cosine. Okay, 10 minutes more, alamak. Okay, so I find this angle, right? Find this angle here, and this is 77/16, but you don't leave the angle in terms of degree. Try to change them to radian. Well, afterwards, when you want to find area or find arc length, you have to use radian. So you found this angle theta here, the angle A. You degree, change to radian, right? Another thing is, I want to find this length here, FB. Because this is the right angle triangle, I use the Pythagoras theorem. FB or BF equal to 18 square minus 4 square. 18 square minus 4 square. And using your calculator, you can find this line FB 17.55. So I now, for this right angle triangle, I know this angle, and I also know this line. So everything about this right angle triangle I know. Okay, next, I want to find the angle on the other side. Now, because this is a trapezium, ABCD, This angle A and angle B, they are the interior angle of this trapezium. Interior angle. So if you remember what you have learned, don't know, from 1 or from 2 lah. Okay, interior angle, you want to find the other one, you have to use 180 minus this angle, then only you get the interior angle. Now again, I told you don't use degree or use 180, you use pi, then minus DAB, the angle here. Then you will get the angle on this side. So I use pi minus this angle over here. Then I get this angle which is over this side. So far okay or not? You know what I'm doing or not? Interior angle. So I use 180 minus this, I get this one. But now is radian, I use pi minus this, then I get this. My answer is in radian. So far okay.
Teacher,
Yes.
the interior angle is for the right angle triangle or the whole trapezium?
Trapezium. This one is for trapezium. Right angle triangle is 90 minus is pi over 2. Is for this part me if you use right angle triangle, but I the whole thing here for the trapezium. So it's 180 minus. If only this part, then it's 90 minus lah. Okay or not?
Okay.
I want to find the whole angle here, interior angle. So it's pi minus this. Any more question?
Now,
No. Okay, no. So now I know this angle and I know this angle, right? So calculate angle BAD already calculate earlier here already. BAD is actually BAF, the same angle, right? Same angle. So calculated already. Then find the shaded area. Now this is the shaded area here. Now to find this shaded area in a red color, I have to use the area of trapezium minus the area of these two sectors, the big sector, the small sector. Then I will get the area outside. Okay, right. One more time. Shaded area is area of trapezium, the big one, minus the area of the two sectors. Area of two sectors, then I get the outside. Now how to do it? Shaded area is area of trapezium ABCD minus sector ADR minus sector BCR. ADR is the big sector. BCR is the smaller sector here. So trapezium is half A plus B times H. Okay. So coming back to trapezium here, A is this one, the parallel side, the sum of parallel side. 11 plus 7, then multiply with this DC. And how much is DC? 17.55. So it will be half 11 plus 7, these two parallel sides, this side and this side. 11 and 7, right? Multiply with 17.55. 17.55 is the distance between the two parallel sides. So this is the area of trapezium, right? Then area of sector, half r square theta. So the big sector, half r square, half 11 square. Angle for the big sector, this side, 1.3, right? 1.3. Then area of the small sector is half r square theta. Half, and this is r, 7 square. Theta, this one, found already, this angle here. So one shot, you put all inside your calculator, answer is 32.48. You check and see whether it's correct or not, 32.48. Then any question, some people will be checking. Those understand one, you check. Those don't understand one, you ask now. Any question or not? Boleh. Tanya soalan. Ada soalan?
correct
Correct.
already, teacher.
Correct. So can follow or not?
Can.
Can, okay. Can, then this is your homework, right? Page 14, self exercise 1.5. You don't know, then you try. Don't know, then you put inside the Telegram group. Then I will do very detailed like this for you, right? So today the two videos, after I save, then I put inside the YouTube. Then I put the link there, you can do it, right? So if no question, then we're going to end the lesson, right? We're going to end the lesson. End the lesson.